गुड मॉर्निंग फ्रेंड्स, कैसे हैं आप? माई सेल्फ सरोसेनी एंड टुडे वी विल डिस्कस अबाउट टॉपिक वेक्टर. As you know, there are different types of physical quantities which are categorized according to their different properties. If we will discuss about the physical quantities, so we will discuss about their different properties. Like if we discuss about physical quantities, they are categorized into two different properties, like on the basis of directional properties, and the second is on the basis of dependency. So all physical quantities are categorized by two types. Firstly, on the basis of directional properties, and the second is on the basis of dependency. On the basis of dependency, physical quantities are of two types. First are fundamental quantities, and second is derived quantities. And on the basis of their directional properties, physical quantities are of two types. First is scalar quantity, and second is vector quantity. So if we discuss about the scalar or vector quantities, firstly we need to know why we need direction for denote or derive any physical quantity. Like there are different physical quantities like mass, temperature, time. We need only a magnitude to derive them. Like if we will discuss about mass of any body, so mass of any body is 10 kilogram. So 10 kilogram is the magnitude of mass. But to express the mass, we do not need any direction. But if we discuss about the displacement, velocity, acceleration, force, and many other different physical quantity, we need to define them magnitude as well as direction also. Means we need both direction or a particular magnitude. Like if we discuss, suppose that this is a box. We are applying, like me, applying a force of 10 Newton in this direction, and some another person like my friend applying a force of 5 Newton in this direction. 5 Newton in this direction. So if we discuss about the force which applied on this box, we need to direction. Otherwise, we can't know about the direction of force, like in which direction force is applied. Similarly, if we take another example like displacement, any body or any car, which start moving from a initial point A. So if we discuss that this body is going to 5 kilometer, but 5 kilometer where? In east side, in west side, north or south? Which direction we are going to going? So we need to express direction here so that we know about the direction of movement or direction of displacement. That's why physical quantities are categorized into two major categories. First is scalar quantities and second is vector quantities. Now first we will discuss about scalar quantities. Scalar quantities. So scalar quantities are those quantities. Sorry. quantities. To represent them, we need only magnitude. Physical quantities, physical quantities which need only magnitude to express or define them. Like example, like time is a scalar quantity because when we discuss about the time, like this is 9 o'clock, so 9 hours, 9 minute, 9 second, or 9 o'clock, whatever it is, we need only a magnitude. We do not need any direction to explain them. Similarly, mass is also a scalar quantity, like 10 kilogram, 20 kilogram, and etc. Temperature. Temperature is also a scalar quantity, like 10 degree centigrade to 70 Kelvin. We need only a particular amount, which is magnitude, but not need any direction. All the physical quantities are scalar quantities. Scalar quantities follow algebraic rule, like algebraic sum. Like suppose that uh, mass of body A is 10 kilogram and mass of body B is 20 kilogram, and we need total mass of these both bodies, then we can total directly 10 and 20. The result will be 30 kilogram. So we can add or sum scalar quantities by algebraic method, algebraic sum. But in scalar quantities, we use algebraic sum, and vector quantities. Now we will discuss about vector quantities. In vector quantities, physical quantities, physical quantities which need direction along with direction along with their magnitude. Means we need both magnitude or direction to define any vector quantity. To define physical quantity, to define them, are vector quantities. For example, force. When we discuss about force, we need the magnitude and direction both, as well as displacement, acceleration, etc. One more important thing, the vector quantities are always follow the vector law of addition. Vector law of addition means we can't total or add directly any vector quantities. Like two forces are applied on this box. First is 10 Newton, second is 10 Newton. But the direction of these forces are same. Both force are in same direction, 10 Newton and another 10 Newton. Then total force, total force will be 10 plus 10 equals to 20 Newton. So according to their direction, because they both are applied in same direction, the total force will be 20 Newton. But if these force will act like one force 10 Newton is applied in west direction and 10 Newton force applied in east direction, then the total amount, yeah, total amount of force will be 10 minus 10 equals to 0. So net force or resultant force will be 0 here. So they, in vector quantities, direction is very important to define them. We can't directly total when we find out the resultant or net vector quantities amount. So they all are follow vector law of addition. Those quantities, to define them, we need magnitude and as well as their direction are known as vector quantities. But if we discuss more about the scalar and vector quantities, there is an important thing which is we should know, obviously. Physical quantities which need direction along with magnitude, but they do not obey or follow, मान लो, obey law of vector addition. Means there are some physical quantities which are defined by their magnitude and direction, but they do not obey any vector law of vector addition, are not are not vector quantities. This is very important thing. Physical quantities which need direction along with their magnitude, but they do not follow or obey the vector law of addition, are not vector quantities. Means vector quantities are always obey vector law of addition. So if any physical quantity which is not following addition law, then these are not vector. These are the different type of physical quantities which are known as tensor quantities. These are known as tensor quantities. Tensor quantities are those type of quantities which have particular magnitude in particular direction, but they do not obey any vector law of addition. These physical quantities are known as tensor quantities, but tensor quantities are not in our syllabus. That's why we are call them only scalar quantities. Only scalar quantities. Means physical quantities which do not obey vector addition, but they have direction as well as magnitude. Both are here, but they do not obey the law of vector addition. So they do not vector quantities, they are tensor quantities, but quantities are not in our syllabus. That's why these all are known as scalar quantities. We defined as them scalar quantities. Now we will discuss about the types of vector quantities. Types of vector quantities. First, polar quantities. First type of vector quantities is polar quantities. So polar quantities are always applied for linear motion. Linear motion. When we will discuss linear motion, then there are all types of physical quantities are known as polar quantities, like displacement or acceleration or force, and different types of physical quantities which occur linear motion, like this is a car or any box moving in a particular direction, then this direction and that. So different types of movement which are showing here, we all are linear motion. This is linear motion, and at the time of linear motion, any physical quantity is known as polar quantities, like displacement, acceleration, force. We can express them in another way, polar quantities like polar quantities are those physical quantities, those physical quantities which have a starting point or a point of application. Means, to define polar quantities, we need a starting point or a point of application, like when we try to move from one place to another, like I'm going to coaching, I'm going to market. So this is the initial point from where I start moving. So this is, if this is the A point, and this is my coaching, market, hostel, whatever it is, this is the point B. So I always start moving from this point. This is initial point. Initial point. Initial or starting point. Starting point. And this is final point or final place, whatever. So starting point is exist here. When we start moving, we have any starting or initial point, like our home, a coaching, a market, whatever it is, from where you start to moving or start to driving, running, walking, etc. All these starting points are exist here. So the displacement from A point to B point is a polar quantity. As well as we take another type of example, like this box, applying a force F in east direction, and then another force is also applied F dash in same direction. Otherwise you can see, like this is in this direction east, and another force is applying on west direction. So this box is moved in east or west, any direction. So box is also in linear motion when it start moving, linear motion. So we will discuss about the linear motion. Then all the physical quantities are polar quantities.